Hey, my name is Steve. Welcome to my YouTube channel. This video will cover the 2019 HSC Mathematics Extension 1 past paper from question 6 to question 10 in the session 1. Here is question 6. The question is, it is given that the sine x equal to 1 on 4, where x in the range of half pi to pi. So what's the value for sine 2x? We can't getting the sine x into the sine 2x directly. We can convert sine 2x into 2 sine x times cos x, because here we have the value for sine x, and we can get the value for cos x from sine x as well, from this equation. So that we have, okay, so we have cos x equal to positive and negative square root of 1 minus sine x squared. Okay, so we can put this sine x into here to have equal to positive and negative square root of 1 minus 1 on 4 squared. So keep going, positive, negative, square root of 1 minus 1 over 16 equal to positive, negative, square root of 15 over 16 equal to positive, negative, square root of 15 over 4. Because the x is in a range of half pi to pi, so for cos x should be negative value. So cos x, okay, so here cos x equals to negative square root of 15 over 4. Then we have all the conditions we should have. So for sine x, cos x, which means sine 2x equal to 2 times 1 on 4 times negative 15 over 4 equal to 2, we got 2. 2 times 4, we have 8. Don't forget the negative sign, okay? Negative 8 square root of 15. So we have the answer B. Okay? Okay, go to question 7. Question 7. So here is a cubic equation. So let px equal to qx squared, qx cubed, plus rx squared, plus rx plus q, where q and r are constant numbers. Q is not 0. One of the 0 of the px is negative 1. For the cubic equation, we have this, the product of 3 zeros is equal to negative b over a. So a, b, so a and d, so here's a, b, c, d. So a, b, c, d represent the coefficient numbers of the terms. So here, the d is q, a also is q as well. So here, the product of 3 zeros equal to negative q over q equals to negative 1. And given that 1 alpha is a 0 as well of the function, alpha isn't 1. So we have another 0 is negative 1. So negative 1 and alpha are 2 zeros. So negative 1 times alpha times another 0 equal to negative 1. So negative 1, we have alpha times beta equal to 1. So beta is the last 0 we want to know, equal to 1 over alpha. Okay, so 1 over alpha. C should be answer. Okay. Okay, let's go to question 8. In how many ways can all the letters of the word P, A, R, A, double L, E, L be placed in a line with 3 L's together? As the question 1, we have to have 3 L's together. 3 L. So we can join these 3 L's together to treat this joint as one letter. And plus extra, we have 1, 2, 3, 4, 5. Another 5 letters. The total numbers of ways for the allocation for these 6 letters. Okay, here's 1 letters plus 5 letters. So total we have 6 letters is 6 factorial. But within these 5 letters, we have 2 A's. That's why we have to divide it by 2 factorial to eliminate the overcounting of these 2 A's. So the answer should be 6 factorial divided by 2 factorial for A. Okay. Now let's go to question 9. Which graph among these 4 best represent this inverse function y equals to cos inverse negative sin x for the x in the range of negative half pi to half pi? And we try to find the difference of these 4 graphs. So for example, A and C are both decreasing, but C is decreasing in a constant rate, but A is not. B and D is increasing in a constant rate, but B is not. Then we try to find the changing rate of the original function from the first derivative. Then we can find the answer from here. And using this formula to find the first derivative of the original function, the inverse cos. Okay, for y dash equal to negative 1 over the square root of 1 minus this x in here is negative sin x. So we put negative sin x into this x. So we have negative sin x squared. And don't forget we should use the chain rule for this term to times negative sin x dash. Okay? So equal to negative 1 divided by, so here 1 minus sin x squared. So we have 1 minus sin x squared. Here actually is cos x. And times sin x, the derivative of sin x is cos x, so negative cos x. Yes, okay, here. So negative, we have cos x positive. Become, this one is, in this range, the cos x is positive. So we have cos x is positive. So eventually we have 1, which means the changing rate of the original function is keep increasing, but in a constant rate. And with the tangent is 1, so D is the answer. Yes. Okay. Alright, let's go to question 10. Question, the function of x equal to negative square root of 1 plus square root of 1 plus x as an inverse function. And the graph of the inverse function forms a part of this curve. So here, this diagram represents this curve, okay? And the question asks you how many points does the graph of the original function and the inverse function have in common? And we have to have one concept for the original function and inverse function is they always have to be 1 to 1, so 1x to 1y. And the domain for the original function is the range of the inverse function. Same thing to range. So we try to find the domain and the range of the original function, and then to fit them over to the range and domain of the inverse function. So for the original function, the domain for here, the square root of 1 plus x has to be greater than or equal to 0. So the domain of the original function has to be 1 plus x greater than or equal to 0, which we have x greater than or equal to negative 1. And the range of the original function since this part has to be greater than 0, greater than or equal to 0, which means this part, this square root has to be greater than or equal to 1. And to the original function, then we have a negative sign, which means that the original function has to be less than or equal to negative 1. So the fx has to be less than or equal to -1. And the domain of the original function is the range of the inverse function. Okay, so which means that this range of original function has to be greater than or equal to -1. And the range of the original function is the domain of the inverse function. So the domain has to be x has to be less than or equal to -1. So we try to find the part of this one on this graph. Okay, so the domain has to be less than or equal to 1. So here is -1. So the domain has to be in this from -infinity to -1, including the -1. And the range of the inverse function has to be greater than or equal to -1. So we have -1 over here, so -1 over here have to be greater than -1. So only this part is the inverse function. And also we have to know the inverse function and the original function is symmetrical by the line of y equal to x. So this line is y equal to x. If this part is the inverse function, the original function should be on the other side, symmetrical by this line y equal to x. So there's one and only one common point of the original function and the inverse function. So the answer should be A. Okay? Yeah, that's all for the question 6 to 10. And I will see you next time for question 11. And if you like my video, please give me a like and subscribe my video. I'll see you in next video.